Hello, Professor. This is Julia Schneider from Survey of Calculus, Math 130, and I am here to record my third video correction. This is from test number 1, and this regards learning target D2, which states, I can explain the parts of the limit definition of the derivative. Some of my main mistakes are the fact that I don't know, this just wasn't, I clearly didn't fully understand it. I used instantaneous, this is the wrong wording and it doesn't really make sense, and I didn't say slope at all or mention kind of the whole idea. So that is the main problem, I would say. And then this does not make much sense. I mean, I wrote here, I showed positive and negative slopes, but not the main function of the limit definition of the derivative, which is to showcase that, what shrinking h looks like, which I will do over here in a second. But yeah, those were some of my main misunderstandings. Without further ado, I forgot to mention just now, this was a big one, that I didn't put as the limit, as x approaches h. This means that I'm evaluating the limit as x is approaching h, and I didn't put it. And this is a huge part. I mean, it says limit definition of the derivative, so that was a big little mistake. But let's jump into how to solve and answer these questions, because it's just much easier than I was thinking it was. So let's go. So this is all number 8, and this is the first question, A, which says write out the limit definition of the derivative. So like I said, it is the same thing as what I wrote in terms of the equation, but what I didn't put below f prime of x is as a limit as x approaches h, which means take the limit as x approaches h. And I forgot that part, so there it is in the correct version. B, explain what rational part of the derivative is calculating. So I meant to put explain what the rational part of the derivative is calculating. Yeah, basically it's a similar kind of answer, but it's, solidified, I would say, and I've grasped a much deeper understanding of all these concepts. So the rational part of the definition is calculating the rate of change of the function. So that's this part, or the slope of the function. So we're calculating the change of y over the change of x, and yeah. Basically gives you the slope of the function. C, explain what the limit part of the definition is calculating. So that is this part over here. So the limit part of the definition is essentially making the change in x equal to 0. So as we can see, h is meant to approach 0. So we're basically making it closer to 0 so that the rate of change is instantaneous. So as h approaches 0, the change in x in the slope goes towards 0. So let's just demonstrate that on a graph. So this says, sketch out an example of how the limit definition works on the axis. So here we have a graph that I drew, and here we can see as h is approaching 0 and as the change in x equals to h approaching 0, the secant line gets closer to the tangent line. So it gets closer to the instantaneous rate of change, as we can see demonstrated here. We have this point which goes to secant 1, and let's just say this is 3, and this is 2, or whatever, and this is 1. Then we have, well, you don't even, yeah, but that, you could see here that this secant 1 line where h is equal to a bigger number, it is further away, the secant point is further away from the tangent point, interception, I mean, like the interceptions of the lines on the function, they're further away than at this point, which is where h is closer to 0, and the point on the secant line is closer to the tangent line point. So yeah, that is my explanation of learning target D2. I hope that you had so much fun watching this video. Thank you for your time. I really appreciate it. Have a nice day.